Now let me discuss about the pin diagram of 8085 microprocessor. It is very important. With the help of these pins, we can connect memories and other input-output devices. So these are very important. Now let us say it is a 40 pin IC. It requires plus 5 volt DC supply. There is pin number 20 is the ground and pin number 40 is the plus 5 volt DC. Then we have pin number 1 and 2, these two are from crystal oscillator to generate the clock. Then there is a reset out, means to any device connected to this 8085 that can be reset. Then we have two pins 4 and 5, serial output data and serial input data. As you see the arrow mark, this is inside input and this is outside output. Okay, for receiving the serial data into the processor or sending from processor to other device. Then the trap is a non-maskable interrupt. It is going to be used for emergency purpose. So trap is a non-maskable interrupt. Then RST 7.5, 6.5, 5.5. These three are vectored interrupts. Vectored interrupts, maskable vector interrupts. Then interrupt request. If more than one interrupt occur, from that we are going to get one interrupt request signal. So then if processor is ready to provide service, that will send one acknowledgement, interrupt acknowledgement. Okay. Then we have AD0 to AD7. These pins are going to be used as address as well as data lines. 8 address lines as well as 8 data lines multiplexed. So you can demultiplex using this ALE signal, address latch enable signal. Then we have exclusively 8 address lines, A to A50. We combine with this A0 to A7, it becomes 16 address lines. Okay. These 16 address lines are connected to the memory. That is of 64 kilobyte memory can be connected. The maximum capacity is of 64 KB because of 16 address lines. Then we have S0 and S1. These two control signal is going to distinguish the operation like upcode fetch or write or read or halt operation depending upon status of S0 and S1. Then we have other control signal for read operation. This read signal will be sent. For write operation, this write signal will be sent. Then we have IO/memory for IO device. This is high. For memory, this is low signal. The same signal will work as IO interfacing or memory. Then ready, if any external device is connected to the processor. So if it is ready to send data, then it will send as a ready signal to the processor. Then reset in. Once you press the reset in on this pin number 36, the process starts execution from the beginning. Then there is a clock. This clock is for external device. If any external device connected, this clock will be used as a input. Then we have HOLD, hold and hold acknowledgement. For this is for DMA controller. This is from DMA controller. DMA controller is going to use to transfer the data directly from one device to another device without intervention of the processor. For that, it requires the buses, address, data, and control bus. These buses are controlled by the under the control of microprocessor. To get permission for using these buses, so it is going to send one signal, hold signal. If processor is ready to give these buses, then it will send one signal as a old acknowledgement. Yeah, I am ready to give the buses to the DMA. The DMA, once it receives old acknowledgement, then we start sending the data from one device to another device without intervention of the processor. So these are brief about the pins of the 8085 microprocessor.